Awesome. So welcome to the June 12th edition of the Data Nerd Herd. So like I said last week, it's been interesting. This is sort of grown into a bit more, I guess, regular, so to speak. So the whole idea is to have discussions and keep things pretty informal, and but always teach people something new. So this week we got Rommel Garcia from Imply. He's going to talk about hot data, or as he says, who says you can't put Sriracha on your data? So I put Sriracha on everything. So this is a topic that definitely, yeah, good. If you're not putting Sriracha on everything, then you're a masochist. That's all I have to say. So, anyway, sorry, I switch here. So how is Nerd Herd different from a meetup? This is an unscripted, informal discussion about a data topic. So Frank's is going to want to speak with you. Yeah, probably. So we're trying to capture, like, I think for me, I have a long history of running meetups and being a part of meetups. And really when COVID hit, it was pretty obvious what was going to happen was the conversational aspects of the meetup were going to potentially die away. Yeah, people show up for the networking, the relationships, and really the whole idea was to kind of preserve those great things about meetups. So, we started out as a Slack group, which I'll get to in a second. But then what we realized is, during the COVID times, we've been able to connect with a lot of people from all over the country, whereas a meetup is usually a localized event. If you have guest speakers from outside, they have to fly here now. So you can kind of, get some great discussions going from people from all over the world. So that's really the goal of the Nerd Herd, is to provide again, an unscripted, informal venue to learn more about data from some of the top minds in the industry. So we do have a Slack group. It's invite only. Message me in the chat or email me at joe@turneridata.com and I'll add you. Or if you know somebody in the Slack group, have them add you as well. So, and upcoming events, Friday, June 26th, we have Jeff Baird, the data engineering manager at doTERRA. He's going to talk about gut-driven data. So this will be a good one. And then we're working on a slew of discussions in July and beyond, so stay tuned for that. And I'll shut up and let Rommel do his thing. So,
all right, let's get to the hot stuff, man.
Hot stuff.
Yeah. All right, well, pleased to meet you all, and thank you, Joe, for inviting me to speak here. So let me know if you can see my presentation here. Put this in a presentation mode. Are you able to see a slide?
I see a Sriracha.
Sweet. All right. That's pretty much it, right?
Okay.
So now, I'm going to introduce myself here for a minute, just so you'll understand why I pick hot data as our topic here for today. So I'm the head of partner engineering at Imply. I've been with Imply for 2 years now. Started out as a director for field engineering, and now I'm managing the partner engineering side of things. I'm an author of a book called Virtualizing Hadoop. So if you work with Hadoop in the past and you Google it, I should show up there and go buy my book so I get some royalty on it. Not much though, probably a few cents per book. So 13 years of combined experience in the distributed systems, including real-time systems, and then GPU as well. I was with Kinetica years ago, and Kinetica is pretty much a company that built the databases based on GPU and a lot of performance tuning as well. And I do like spicy food, although I have lessened my intake of spicy food because my throat starts burning if I'm not very careful about it. So love Indian food and any other spicy food out there. So you've probably seen this, right? There's a lot of terms thrown around in your company, in your organizations, in the industry. We've heard of hot data, real-time data, We heard the term fast, SLA, ETL. Probably you're all aware of that, right? In batch data processing, stuff like that. But the whole focus here is to, put some clarification around what really is a hot data. So once we start talking about hot data, pretty much when you hear streaming data, when you hear millisecond response time, when you hear streaming, when you hear, real-time data, fast access to data, fresh data, those are pretty synonymous. They mean the same thing. And the difference only there is, the age of the data and how fast we can look at this data. So the genesis of hot data is also important, right? Because not all data are the same. Not all data are hot. Not all data are cold. And we have to look at this first from, where they originate and how, what's their age, right? Until we consider them to be not so important anymore. And there's a whole lot of industry out there. You have your typical IoT homes nowadays. You have sensors on your HVAC system. You have sensors on your water, sensors on your smoke alarm, carbon monoxide, and stuff, right? There's a company out there called Residio Industrial Specialty. So they built a SaaS model to receive all of the sensors across 150 million homes, and then they do something with it. Power company, right? They now rig their power meter that we have at home to emit data on how much we're using, right? And then sometimes they have a way to determine, what kind of appliance plugged in into your first floor, into your basement, right? And then have that kind of context to get a more understanding on your consumption for power. Cars, right? Tesla, about driverless car, right? They drives itself. It uses GPU and sees what's there in front of the car and just keeps it moving along with GPS data. All of that is real time. Supply chain too, right? So they want to keep track of where products are moving at what time. Those products have a refrigeration system inside as well, especially if those are produce, right? And those refrigeration system also emits data, just so the driver knows if the produce are on a good temperature, because that might take a day to essentially ship it from point A to point B. IoT is another example, right? And so on. There's so many. One interesting thing that I learned from flying so much in my job is that the planes actually have a I would say I think a minute or 5 minutes, if I got it correctly, of understanding if they're going to hit a bad storm, and so they go around it. And so that weather information is also hot data. Now, all of this information they monetize, right? And this can equate to, for instance, on the power company, they can route the power supply, from a specific area to a different area, because if they generate, let's just say 100% power, and the consumption is only at 70%, then that 30% is a waste. They cannot monetize that. So the sooner they know where consumption demand is going in real time, then they can adjust their power generation as well in real time. And especially for network systems, as you can see here, network intelligence, right? So the sooner you can find out if there's a fraudulent access to your network, then the less damage that malicious attacker can do to your environment and to your data center, right? So it's all about maximizing and optimizing efficiency and also revenue. And that's why there's dollars attached to it. This data could be milliseconds to weeks of age, and it's still useful. But essentially, this data will fall into cold data, and the reason being, there's always going to be historical information that will be leveraged by businesses to understand, patterns and predictions. For instance, with the network, right? If once you have an event and it's a malicious event, you can backtrack and understand how this malicious event came up, right? And then go back to your historical data and then start modeling this kind of pattern where the malicious event went through. And so, based on machine learning, algorithm feature modeling, and stuff like that, once you've done it, then obviously you can add that into your operational aspect, and that's why historical data is used to make decisions of more of a strategic way versus in the hot data, which is more operational related decision making. Before I move on, guys, I've finished 2-3 slides here. I want to make sure that if you have any questions that we tackle this before we move on to the next slide. Can you guys hear me?
Yeah, can hear you.
All right.
Yep.
All right, let's move on then. So the use cases for hot data are pretty much pervasive, right? It's not just in one area, as you saw earlier. This risk and fraud analysis on the hot data, digital ads, right? For instance, once you are searching in Google, for instance, for a specific product, and then a minute later you go into Facebook, Facebook is already showing you what you've searched for. So wherever you go, I mean, they track you now and they show ads. And so the events that you created on the web are pretty much captured in real time and then fed off to different channel of application like Facebook, where they can show you more stuff until you buy it. And that happened to me because I started searching for a smoker, and I have the Weber Smoky Mountain, and that's what I've been searching for quite a while, and I keep seeing it on different pages. And so dove into it and then finally pulled the trigger on it, and I've been using it for the last 2 months. Network performance as well, right? So a lot of the security-related type analysis, like DDoS attack or intrusion detection system, right? You really have to watch the network logs in real time. You probably heard of the streaming telemetry. That's a new thing these days because that will allow all of the network equipment to now push events in real time as opposed to writing it in a log file and then something else picks it up to shoot it over. So hot data becomes hotter at this point, right? Clickstream is another one, and we already talked about that with the digital ads. They pretty much go hand in hand. But the other thing there is the user behavior analysis, right? Like they would like to analyze, what part of the website can convince you to start, buying things. With your clicks from here to there, they can tell if you're moving away or if you're going closer to buy the product, then they will, give you more information as you're on the web page. So all of the stuff are pretty much the typical use cases for hot data. Now, I touched some of these earlier, where there are really, problems out there that needs to be solved now. Anomalous network access is one. And then you also have, if you have revenue generating applications, say, for instance, the travel industry, which is heavily impacted by COVID right now. But the travel industry actually are using applications provided by these companies who have the backbone for information on booking flights, cars, hotels, you name it, right? And so all of these applications are revenue generating app. And so if one of them or more goes down, then that's a revenue loss. And so what engineers does, they look at these logs from a consumable perspective. And once they see pattern that an application will go down in a few seconds or a few minutes, they try to mitigate that right away and make sure that that app doesn't go down. Fraudulent transactions is another, especially in the credit card industry, right? I'm going to give you an example. A few years ago, I was in Texas visiting a customer, and then I got a call from USAA. And USA said, hey, we just intercepted a transaction in Florida, and the transaction is buying a new MacBook Pro costing around $4,100 total. And they were like, did you make this purchase? And I told them no, because I'm here in Texas right now. And the reason why they called me is they can track me on the app that I have on my phone. And so it didn't make sense for that transaction. So they flagged it right away. And I asked them, so when did this happen? They say right now. So they were able to take a look at that in real time and prevent the fraud transaction from happening right away. Product pricing adjustments, I would say this to be, some of a gray area, but it makes sense depending on what the retailer is doing. For instance, in a given day, they actually can make product adjustments several times. And this is due to competition information or leveraging relationship with the suppliers of the product, where based on demand from a historical information perspective, then they can make those adjustments as well. Adverse events, so this could be security related. This could be healthcare related as well. Like for instance, at the hospital, right? All of these machines hook into a particular patient. You can funnel all of that machine information to an application that monitors the patient, and then based on a given pattern of blood pressure or heart rate and stuff like that, temperature, right? And if certain thresholds are met, then a cardiac arrest might happen in few minutes and stuff like that. So that can be prevented, right? So so those are really good use case for solving problems with real-time data. Obviously, targeted promotions, and I've already explained this earlier. And then bad production yield. I came from a company in the past, like late 90s, early 2000s. I used to work for this company called Perkin Elmer Optoelectronics. So they are a manufacturer of electronic parts on a printed circuit board with IC chips on it. And this was the part of the space shuttle at NASA. And so it has to go to like a rigorous vibration test, temperature test as well. And our goal at this company was to make sure that our yield is pretty good, at least 98%. The yield basically means, hey, if we have this much of raw materials and we expect to create 1 million products out of it, then that's 100% yield, right? But if we only created 990 million, I'm sorry, 990,000, then that means that our yield is still good, because that's like 1%, right, or 10%. Sorry. Well, at that point, it's not good anymore, right? Because you're now falling behind the 98 percentile yield rate. And so all of the machines that touches the raw material in a production line actually emits data, and they have their own set of quality checks before this machine handed over to the other machine. And so if you capture that in real time, then you can stop this one machine from creating bad products, right, in real time. Because sometimes a machine can generate 1,000 parts per minute, and that costs money. So all of that problem sets are pretty much good candidate for solving problems like right away.
Hey, Rommel, I have a question for you.
Sure.
Yeah, so you mentioned a lot of use cases here, and I'd be curious to get other people's impressions. But like, how prevalent do you see like hot data solutions and approaches right now versus, I guess, maybe the more traditional batch approaches that we've had for decades?
Oh man, it's well, it's been going on for years actually. So so let me tell you who are the frontliners to this, right? Who had the very first solution in place, the stock trading, Nasdaq, right? Those are all hot data because financial information goes really fast, can change several times in a second. And then next is the oil refinery, right? Because they have this oil refinery plant sometimes in the middle of the ocean, and they have sensors attached um, to the well, right? And they measure pressure, they measure temperature, level of oil, and so on, right? So all of these are pretty much the ones who started it, and then due to the web explosion, now you are seeing patterns of properties getting, its electronic counterpart. Say, for instance, your house, your car, um, your buildings, even, right, hospitals, and so on. So the companies really that are shining pretty well on this hot data use case. I don't know if you've heard of them. Databricks is one. Um, and Databricks are really in that area, enabling organizations to capture hot data. One of their product called Spark Streaming is responsible for ingesting from many different data sources in real time. So that's the mechanism to basically suck the data out of it. And then the other company that goes along with it and complements it really well is Confluent. Confluent has this product called Kafka. You probably heard of Apache Kafka, right? It's been there for a while now. And Kafka becomes the publishing and subscribing mechanism in real time at scale, to allow applications to consume hot data and do whatever they want with it. So even retailers are now putting sensors at stores, right? They also have sensors in trucks that's got refrigeration system. Um, they also can monitor the truck drivers because the truck emits information on where it's currently at, and they would like to minimize truck drivers stopping so often, right? Because they had to meet a deadline and really target the delivery of produce products to the retail stores. So it's no longer the IoT area where that's a natural fit for hot data, but it's now crossing over to retail stores, to hospitals as well. And then you also see this in the financial industry, right, where they are now keeping track, not just at a high level, all this credit card transaction, but at its lowest granularity as well, making sure that that transaction is not fraudulent. Because once you start talking about AI and machine learning, it has to look at unaggregated data, right? And so now the pattern is looking at every single transaction and see if that's fraudulent or not. So it's becoming more pervasive now. Talking about maybe 10 years ago, it's not that pervasive, but these days, we're pretty much there. Did I answer your question, Joe? Was
Yeah,
that
yeah, you did. Yeah, that was me. Thanks.
Mm-hmm. All right. So, what's the correlation between hot data and real-time data, right? Now, we've talked about hot data, and it goes through a streaming engine. And we talked about Databricks earlier, which is having the product called Spark. And streaming engine is responsible for capturing all of this hot data from many different places, from many different protocols, from many different sources, from many different networks. And typically what happens is, okay, I have this hot data, say for instance, my at home, right? I have a sensor for carbon monoxide, and that would emit, probably levels of carbon monoxide, current temperature of the house, location of the sensor itself, along with the sensor name, timestamp, right? Battery level, and so on. So that gets emitted to a streaming engine, and then the streaming engine will read metadata from a metadata store. And now the reason why it does this is to enrich that data more. Say, for instance, it would attach my account to that event, right? Just so they know that, it's this address owned by Mr. Garcia. And then once the streaming engine wraps that metadata information around that event, then it goes to a queuing system. And a queuing system, what it does is it allows different applications like Kafka to subscribe to it and listen to that event, and then do some analytics on that data. So the pattern here, as you can see, is that we have the hot data that turns into a real-time data, and then now on the consuming apps, it becomes a real-time analytics. So when people start talking about hot data, real-time analytics, they're all the same. It's just that they mean differently in a different area of the movement of the data, right? So as you can see here. So as it progresses, that data gets richer and richer, and it becomes more meaningful up to the point where people can start analyzing it. So, the distinction is there now, right? We're good with it. We know what data means. You know what real-time data means. We know what real-time analytics means. And that path, essentially, right? The hot data is still hot data, right? It's just that once it goes through a data pipeline, the meaning starts changing, and it becomes more valuable for business to actually see that data. Now, the speed to visibility to this is really fast, right? Applications will be able to have this visibility into milliseconds level up to seconds. And once you hear real-time data, real-time analytics, that's the kind of range that you would want to have access to your data. You want to know it right away and do something with it if something goes wrong. We talk about Spark and Kafka. What we didn't talk about, which will be the bigger part of the conversation once we're done establishing the terms here, is Druid and Imply, where I work at. Our founders actually created Druid, and it's a place where you can analyze your data, really fast and at scale, and lead to the term called self-service analytics. So we're gonna dig deeper into how Druid can support real-time analytics, allowing you to analyze your data really, really fast. So that's the path, right, for analyzing hot data. And you might ask, because on our previous slide earlier, hot data eventually becomes cold data, right? So how does that work in here? Now, streaming engine actually has a copy shipped over to a data lake. Now, data lake, I don't know if you've heard of this in the past, but data lake essentially is a place where you dump all of your raw data. You've heard of Cloudera, Hortonworks, MapR, AWS EMR, or Google's Dataproc, which is their own Hadoop platform. And all of the data these days are landing into a data lake for long-term storage, raw data up to the petabytes level. And so streaming engine also writes that information into data lake for historical analysis purposes. And once it's in data lake, that gets coupled up with other batch data as well. Now, batch data, this information could be master data of the information of the product, could be master data about organization or stores. Could be master data around suppliers that you work with, right? So these are all internal. So you have your supplier, supply chain management software, and so on, right? So those are all operational within a business, and a lot of that are batch driven. And so what organizations are doing today is that they're enriching their data out of that via batch, because that's going to help them with their business. And so batch data will never go away. It will always be there. And so once it's in data lake, obviously that's ready for consumption by the data warehouses. And these data warehouses are great for a analysis of the data in a interactive fashion, where your queries could be in the high seconds to minutes. And this is your typical star schema. You can create your aggregates in there and expose it to consuming applications or consuming users. And what happens there typically is the prescribed method of presenting the report to the users. And there's not much really you can do to backtrack and understand why numbers are low or why numbers are high. And that's because it's aggregated. And once it's served to you, that's the extent of what you can do. You cannot go and backtrack and understand the granularity of how the numbers are, say sales numbers are low, or why a certain pattern within our network where we have a spike of 1 gigabytes per second of access in a particular network point. So data warehouses has their place, right? And they're going to be there. They're not going away. And the machine learning and AI are really relying heavily on data lake information and sometimes on the data warehouse. And the reason being, sometimes data scientists, they'd like to dabble with the raw data and prepare the kind of data that they want. Maybe out of 1,000 dimensions, they only look at 4 dimensions, which are critical to what they're doing. And so they start creating their own aggregates within data lake. Sometimes EDW already has prepared information there, ready for consumption by the data scientists as well. And so you see here the bar, right? It's touching both EDW and data lake. Now, the pattern that we see too is that the machine learning and AI feature modeling and machine learning algorithm development is now crossing to the consuming applications as well. And one of them is Druid. And we're seeing this pattern from organizations who's adopting it. And they're enriching, and they call this the advanced analytics, where it's no longer your typical reporting, but it's coupled with what AI or machine learning algorithm is telling you, and present that into one holistic information, and they call that advanced analytics. And the speed to visibility, obviously, is not as fast as real-time data, right? So this could be in minutes to hours. I've heard of an organization where they query their data in data lake, and it comes back after 26 hours. So you have to wait for a day. And that's due to the fact that data lakes are not really designed for fast access to the data. It's really batch driven. But the power of it is, you have this huge amount of data that you can crunch through, but you have to wait for a long time. One of the things that a lot of the Apache Druid community really likes about Druid is that that challenges in data lake, where if you have a whole boatload of data that you want to process and you want the speed to visibility in the milliseconds to seconds, they ship that data over to Druid for processing. So we're seeing that pattern as well. Questions here, Joe and team?
I kind of maybe open it up to others. I do quite a bit of talking myself. So I guess what are some real-time use cases or patterns anyone in the discussion seen so far?
Yeah, I'd like to know that too. If you heard of real time and they told you what it means, I'd love to hear that as well.
Or I suppose another question would be, if nobody's really doing real time,
Yeah,
curious why.
good question. Yeah, I know the healthcare space is kind of like a laggard, and they're still solving the problem of business to business integration. And you'd be surprised that they're still dabbling with EDI. You know what EDI is, right?
Yeah, yeah, wow.
That's been around since what? Late 80s, early 90s?
Yeah, it's ancient.
It is,
Yeah.
yeah. Um, yeah,
Hey, Rommel, I have a question.
sure.
I believe you went over this, but what industries are sort of the, in the forefront of real-time event streaming? Do you see a pattern
Yeah,
within
in
a?
this case, the media industry, think of Twitch or the telco company that provides subscription to video channels. You have Netflix as well, right? So those industries are definitely in that bucket. And then IoT is another. I mentioned Residio earlier, where if a company specializes in IoT integration or IoT data processing, then they're in the bucket as well. I don't know how you call that industry, right? Because I really don't know what they call their business, but if you hear IoT, that's one.
Do businesses generally start with a problem statement? Like, do they say like, hey, we need to do something better, or like we're looking at a new use case?
Yeah, so well, it comes from two areas, right? So one is, say, for instance, they're starting from the ground up. And so they would like to enable their organization to do real-time analytics, right? And the way how they express their problem is, like this. It takes us about 6 months to go to market, and we don't have visibility into what our users are doing in our web application in real time, which affects our ability to do A/B testing. Meaning, if you want to create new features in your web application or your game or whatever, then it's really hard to make a decision what new features you have to build if you don't have any real-time insight into what your users are actually doing with your product. Another would be there's a need to enable a company to reduce costs in terms of, let's say, in the supply chain area, right, where the product comes out of the manufacturing plant, and then a truck comes in and picks it up, and then it goes and drops it off to a distribution center. It could be Amazon's facility and whatever. And then after that, it goes into stores. And then from the store, it goes to the shelf, right? And if you have visibility into how much money is involved in just touching the product, making sure it reaches its destination in real time, then you have the ability to prevent more costs involved in that matter, right? Another would be revenue generating need. Let me tell you an example. Let's say you are a online company that sells a whole lot of stuff, from kitchenware to furniture and to everything, right? And you can do two things. You can optimize the price of your product, and you can also optimize your ad promotion by targeting specific customer of yours on your website based on historical buy, and also where they're currently at on your page and what products have they seen in the last 10 seconds, right? So these two things could be a goal to drive more revenue to them. And with product optimization, typically you can increase your revenue from 5% to about 15%, right? And if you're earning, maybe 500 billion a year, then you can add more value by just doing this use case, $2 billion more, which is a lot of money, right? And then obviously the typical Amazon way of doing things where they recommend you different products based on your previous clicks, right? So if a company don't have this yet, then that's where they're headed. Does that help at all?
Yeah, that helps. It sounds like this type of architecture sits in the middle of some very, very important projects, from cost reduction that can go all the way up to the CFO level to new revenue streams that can touch.
Yeah, definitely. Yeah, the discussion is pretty much high level, right? Because it becomes part of the strategic objective of the company, right? The end goal is to make more money, right? And if you have a way to make more money, then what I described to you is in that critical bucket, right? Because it adds more revenue to the company.
But how would an engineer introduce this to a business? Like I said, this touches a lot of different business units. It goes up to the executive level, high visibility. What is a strategy that an architect could take to find business units that will want to invest in this type of technology, that will want to kind of pilot this kind of use case?
Great question. Yeah. What we've come across with organizations is that they download Druid, play around with it, and what they do, and this is very important. There's a big distinction between kicking the tires and then solving a real problem, right? And so the engineer and architect really has to know what they're doing. The first thing that they have to know is what problems from a data perspective do we have in the organization, right? If they understand that fully, then the second thing that they have to do is do something with it, which means finding a product that would solve that. And so if they have a use case that they know, or if they have a business analyst or a guy from the business side expressing frustration around some issues that they have with their current system, where they think they're not there yet from a data-driven organization, right? Then the engineers and architects are forced to do something to help them out. And so that's kind of like the driver and motivation for them to go elsewhere and look for a product. And then once they download the product, right, then that engineer or architect then has to start tinkering with the product and understand, hey, I understand my problem on the business side, so I'm going to look for functions that's going to solve it, right? And so initially they would do like a proof of technology. So just play around with the tech. And once they know that, hey, this could be useful, let's try and start putting data into it, right? And that data is real data, right? And then once data is into this real-time product, then they can model the schema. And schema in this way is, your typical database table, right? And understand what kind of aggregation or granularity you would want it to be. Say, for instance, if a retail company makes a decision weekly, then you can aggregate your data into a weekly aggregation. Or if they aggregate it by the hour, then aggregate by the hour. And the reason why you aggregate is because you don't store data that you don't need. You only store that you need, right? And that saves you money too. And so once data's in there, they model it, they query the data, and if the experience is really great, then they go back to their business and say, hey, I've heard your problem, did my initial analysis, here's what I've seen, right? I'm going to show it to you. This looks like a good starting point to make the scope of what I've done bigger and make sure that this is real so we can take it to production, right? If this is the real deal for us. And so the architect, the engineer, depending on their skill set, how good they are, they might be able to do this on their own, or they engage a vendor, right? Or their partner that knows the product. And so the advantage to engaging a vendor or a partner, right? Or whoever is there helping the company from a business perspective is that the risk of doing this is really low, and you can create a solution a lot faster, right? And then do more with what you have, as opposed to having the engineers. And we've seen engineers doing this, say, for instance, I work with a retail company, and they've been trying to push data into this real-time product, which is Druid. And they've been dabbling with this for 6 months, and they couldn't even solve the problem of ingesting 200 gigs of data, and they want to arrive at 60 terabytes of data. And so the lack of knowledge, right? Because there's just so much data that you can, or so much information that you can go into the Apache community, right? There's a lot of like tribal knowledge that didn't get to the Apache community page, and so the tribal knowledge actually exists from the vendors, and so they, we help them out, and we're able to put them into productions 2 months later, as opposed to them looking at this 6 months, and that was 60 terabytes of data. So there's definitely a plus when this architect and engineer starts involving a vendor that has that expertise to work with these different real-time products. Does that help?
Yeah, that's awesome, Rommel. Thank you for that. So it sounds like it's really easy to spin up a cluster on your own and give it a run without any help. And if you need help, there are open source communities as well as vendors to kind of make sure that you're successful. So thank you for that.
Yeah, you're welcome. Great. So I have 9 more minutes, Joe, and I don't know if I have to stop before.
Well, yeah, let's see. Does anyone have any questions or comments so far? The group has been abnormally quiet this time around, so
It's Friday.
Yeah.
I think they're ready to go.
Because I have a controversial question. If nobody's going to ask anything, so I'll.
Yeah, go ahead, man.
Yeah, I mean, and it's something I've been struggling with for a bit. I kind of go back and forth on this. I mean, on your slide, you have EDW and batch data. I mean, and it seems with the prevalence and the growth trajectory of real-time and hot data, part of me kind of wonders what the future of the data warehouse is. Like, will it be necessary or relevant in the next decade, or does it change into something else, or does it just coexist along something like Druid, or it's? I'm just kind of trying to understand the place of a traditional data warehouse in light of real-time data. So, wondering if you have any thoughts on that, if anyone else in the audience has thoughts on that. So,
yeah, I would like to hear from the audience as well.
Well, as a follow-up to that question, are there things that we can't yet do with a platform like Druid that we can still accomplish inside of a more traditional data warehouse, like crunching the large computational fact tables and stuff? Or is that stuff that we can actually do in an engine like Druid?
Yeah, so great question, right? So I'm going to answer this 2 ways to satisfy you and Joe's question earlier. EDW will stay, and the reason being, EDW is really designed for your typical, fact to dimension, fact to fact joining, stuff like that, and organizations like to make the data bucketed in a way where it's a lot easier for them to consume, and that's why star schema is very popular, right? And it's just the way how they do things, and it solves the business operational problems, right? So EDW really is solving 2 problems for organizations. One is making the company more operationally efficient, and another would be finding more opportunities to squeeze more money out of their existing product. On the real-time side of things, right, it's net new revenue most of the time, or big impact to existing product suite that companies are selling, where they can get more money out of it if they implement real-time, analysis of their data. Druid, on the other hand, cannot support fact-to-fact joining. It doesn't do that. Druid, though, released a new version recently supporting fact-to-dimension joining, which you can do. So now Druid is crossing from a hot data real-time analytics to a warm analytics, and Druid doesn't have a really rich SQL semantics yet at this point, right? Because SQL is fairly new to Druid. And so a lot of your stored procedure type processing or 2009, 2011 SQL semantics compliant, that doesn't exist in Druid. And so really the general distinction between the two, which exists for the last decade or more, is that there's always going to be people looking at the data differently, and they don't really care how long the data comes back to them, right? As long as they can use their existing tools that they're familiar with, and then life goes on. There are other users where they want a better experience, and they demand more of a better product from a performance perspective, and then visibility to data right away, right? And these guys want different toolings, and that's why you see, organizations buying Teradata along with Vertica, right? Or you have BigQuery and then Druid at the same time, right? So you see all these patterns. So not one organization will not, they will never use EDW for everything. You will see, pockets of different real-time apps along with EDW, and the real-time apps will actually feed data into EDW at some point for historical analysis purposes. So both will exist, and I hope I clarified some of the confusion there.
Well, thank you. You mentioned the star schema that goes in a traditional EDW. How does, I guess, the typical schema design differ if I was to start putting data into Druid? Is it more of just like a JSON object store, or what would that look like?
Yeah, so the formats that Druid support from an ingest perspective, you have your JSON schema, you have your Avro. In the IoT space, Avro is very common. JSON as well, but far more on the Avro side, because Avro is more optimal than JSON. And then you have your typical text file, right? And then you have your binary file in Parquet or ORC format, which are the formats in the data lake space. And once it reaches into Druid, it's got its own format storage, which we call index or segments, right? And it's a highly optimized storage for analysis purposes. But essentially, from visibility perspective, it's a table. So prior to Druid supporting joins, you have to flatten your data. So if you have multiple data set that you want to analyze at once, then you have to prepare it in the data lake, run a job that would then create one single file out of that, and then push that single file into Druid. That single file could range from gigs to petabytes, right? And push it into Druid. The join support with Druid that just came, you can support fact to dimension join, which is essentially a star schema. It's just that the left side of the table, which is your fact data, can join to multiple small dimension tables. So that's available now, but it cannot support fact to fact joining, which data warehouses can do. So when you here, let me I think from a visibility perspective, it might be easier than just talking about this, right? So if I go here to data sources, this is the UI for Druid. And, I see these are essentially tables, right? So Druid exposes these are tables. And you can actually query those. So if I go to the query tab, I can go into network streaming telemetry and query that. Let's just take that out. And for simplicity's sake, let's just do, hey, just count this for me. So, the last digit is 4, right? And now it's 9. So this is actually in real time. So this is ingesting from Kafka. So you can query your data while you are ingesting at the same time. And you have visibility into your columns. These are essentially your columns right here. That's a lot. And Druid can support up to, we've seen like 2,000 columns in one table, which is a lot. And it still works. And your typical data warehouse can't support that kind of, granularity, if you will. Data warehouses are great for aggregated data at a very high level. But once you start talking about, I want to see very low granularity, but having the ability to aggregate it at a high level at the same time as well, Druid will be a good place for that. Great question, though.
So a follow-up to one of the other comments you made, you talked about, converting files in batch format basically out of the lake and then pushing that into Druid.
Yeah.
In my mind, the primary use case with Druid is just like you've drawn up on your diagram here, like you'd want to pull it directly off of Kafka or Kinesis or something similar. What would be the use case for, I guess, pushing slow data out of the lake and into Druid rather than just, I guess, working on the data inside the lake itself?
Yeah, so Druid's model, and pardon me for saying push early, it's actually a pull. So Druid ingestion mechanism is pull-based mechanism. And so Druid has a what we call connector into the data lake, and data lakes are much Hadoop, right? And so you just have to define your MapReduce job into Druid. And then that MapReduce job will then be sent over to the data lake, and the data lake will do its job to grab all the data and then create the segments out of that. And then that gets pushed into Druid. The other avenue, which is more native to Druid, we have what we call the native batch indexer, parallel indexer, which mimics the behavior of a Hadoop MapReduce job. And so you define that job, and it will pull it from the data lake. So really, you don't have to do anything in the lake from a configuration and coding perspective, because Druid will tell the data lake what it needs to do, and then it shoots off the data from there. And we've seen, you can ingest a terabyte an hour or faster, depending on how much resources you have in a data lake.
Thank you.
All right. Joe, I'd like to be respectful of your time. I can stay longer if needed. I know we're 2 minutes past the hour here, and I can go on. I have a meeting at 3 o'clock Eastern, which means I have 28 more minutes to spare if I need to stay here longer, and I'd be happy to do it.
Yeah, I'll leave it up to the group to make a vote on that. So I'm open to either way. So,
can I ask one more question?
Sure.
I know I've asked a bunch. Like with a lot of these newer technologies, there oftentimes isn't a lot of material out there on how to implement it, best practices, that sort of thing. Where would you recommend if my team wanted to start playing with something like Druid? Where do we go to figure out the right way to start implementing it?
Sure. Yeah. So you can go to the druid.apache.org, and I'm showing it here on the screen. And so there's documentation here, tutorial that you can follow through. And it's fairly easy, because what I've shown you earlier, this is called the unified console, where you can ingest data by just filling in the information. You don't need to be, for instance, a Kafka expert, right? And I'm gonna give you an example. So if I click to Kafka here, connect, it makes it really easy for you. Put the Kafka topic in there, and then the IP for the Bootstrap server, and then I click apply. Now I'm seeing the data, and that's fast, right? So Druid is now pulling data from a Kafka server, and then I can go parse it, right? And it automatically detects the dimensions and the format as well. That's why it's able to pull that information out. And then parse time. Sometimes it just creates it automatically, because some formats of the data here are not right off the bat easily recognizable. So if I would have to say, for instance, order date, right? Pick that order date here, and I know the format, and I just have to type it in here, say, Y, month, day, hour, minutes, seconds, and apply it, and it would automatically pick that up right here. Wait, what did I do here? So it should not have done that. But anyways, I might have done something wrong. Month, day looks right to me. But anyway, so let's just take this out for now and apply that and say transform, right? There's nothing to transform here, and click on, you can keep it going up to, it goes to the edit spec, and then you can submit, and then it would automatically create the data source for you, right? So you don't have to go write a script, and you can follow through the tutorial here. It does the same thing right here, as you can see. And there's also a place where we make it easier, right? And that's why we exist as a company, because our founders created Druid and they realized, hey, we need more toolings around Druid. So you can go here and click Get Started, and then you can download. If you have a AWS account, you can try it in the cloud, or if you want to do it on your laptop, just download the Imply here, put your name on it, on-prem style. And then we have documentation that you can follow through. And if you're running it on your machine, there's a quick start guide that you can follow through and start running, load data file, and start analyzing it as well. So there's a lot of information here that you can start leveraging if you want to play around with Druid. And one thing that makes this easier too, the unified console that I showed you earlier is for operational purposes. And the visual, for instance, this one right here, this is Pivot, so this comes with our platform. And it's a little bit different than the unified console, because the purpose of this is for people who are used to the BI space, right? Visualization of the data. Then you can go to a cube, say, for instance, let's say, store sales data. And then you have different kind of metrics, and those metrics could be, calculated discount based on the data, or you can do multiple selections of it, right? And then pick, sorry, let me say, for instance, product name, just pick it here, and then drag the time, because Druid has a global time index, and what it really does for you is analyze trends based on time, and time is native to Druid. And so I can go back to the table here and see, okay, wow, I'm selling a lot of Canon wireless fax, right? I wonder how many people are using fax still out there, but they still sell them. So now you can analyze, based on this rank, that, hey, how come I'm not getting money out of these products and I'm losing money on this, right? And so you can start analyzing, which store or which country is this from, or city. So I want to find out, where is this being sold? You can just drag and drop. And now it's in Netherlands and Eindhoven city. If we have the store information, just drag it here, and then you can go directly at the store level. And from there, you have to then talk to the people there and talk to the analyst, merchant, representative at the company, and understand why. And this could be related to high costs in the supply chain, or the product pricing, is not big enough to gain profit out of that. So all of that information can be dumped into here for full analysis of your data as well. So root cause analysis is pretty good with Druid. And so, this kind of visualization is very useful. And this comes with, when you download it from our site, you have Pivot, so you can work with it. And then this is the dashboard as well. So you can create the dashboard with many different kind of chartings. You can customize the way you want it. So that's extra from the open source. The open source Druid just shows you this, right? But if you download from Imply, then you will have visibility to this as well.
Thank you.
Any other questions, guys? Cool. All right. So I think we talked about the Spark, Kafka, and Druid earlier, but more importantly, with the Druid side of things, really what data warehouses can't solve is the amount of people accessing the data that would want to have low latency to the data processing. And so they look elsewhere, right? Because data warehouse are great for like small set of users hitting a specific table with large query data sets. It's great for that kind of workload, but not high concurrency and low latency. This will get interesting for you, right? Because we just talk about the nature of Druid from a data model and speed perspective. But Druid really was created out of the need for solving, data problems that entails looking at time, and at the same time allowing the analyst to do search. And once you do search into RDBMS databases, it's really slow. And so if the SLA is pretty tight, then you have to look elsewhere. And then the all-up type of querying data, like, you have a table, right? And then SQL, or you have top N, or you have the aggregation of the data, the day, hour, weeks, months, years, and also having the ability to represent your data into a typical BI tool, right? So you want to have that kind of experience so that there's less uphill climb of learning curve for that particular user. So Druid really is the intersection of, one time series databases. You've probably heard of Timescale or InfluxDB or Prometheus. These are very popular time series databases, and they have their own place. They're really good for operational aspect. When I say operational aspect, the amount of data you can store probably in there is just, days to weeks. Because they typically come with the challenge of, once you start talking about storing months or years of data, they don't scale that well. They're designed essentially to scale vertically as opposed to horizontally. So it's kind of like a limiting factor. And so once a user of this product starts talking about, I want to analyze my data in a different way where I want to also search, not just look at time functions, but having the ability to do aggregation easily, and also estimation, algorithm, statistics, and so on, then that's not a good place to be. And the other area where Druid is borrowing concept from are data warehouses. You have your typical Snowflake, Teradata, Greenplum, Google BigQuery, and so on, right? And I'm just showing you a subset here. Data warehouses, they really they pioneered the concept of, creating the optimal representation of a data into a table fashion and column fashion, and then allowing users to access it in a very user-friendly way by writing English as opposed to code, right, which is SQL. And then also having the ability to do the aggregation. So those concepts, and then being cloud native too, right? Because Druid is cloud native. So those concepts were borrowed, and then Druid incorporated that. And then you also have search, right? Because so search, we see this all the time too, where organizations are, say for instance, using Elasticsearch, and when they started, it works really great, and they're storing about 3 months of data. It does what it does well, but once you stretch out how much more data you can store, and then piling on top of that some complicated queries, or when I say complicated, it requires, or it presents itself to be a complex query, a lot of aggregation, right, a lot of filtering and stuff like that, then it falls on its face. And so they're looking at a system where they say, hey, I'd like to still use search into my use case, but having the ability to store more data and then putting a lot of complex functions into my query, like estimation algorithm, like the percentile, or histograms, or aggregation on the fly, right? And a lot of filters on it. And so once you hear people talking about that, then they have to look elsewhere. And so the concept around search has been powered by Druid as well. And so all of the strengths that this different system has, Druid essentially put it all together in one package. And this is what Meta Markets back in the day built. And the people who built it are the ones who essentially incorporate our company here at Imply. So they had this problem of, hey, we tried using Hadoop, we tried using Cassandra, we tried using OpenTSP and Solar and the stuff like that. It just didn't work out for them. And so what they learned from those different exercises that they have had, which didn't yield any result, was that, hey, you know what, we can borrow these different concepts, right? And then just build a product. And so they started building Druid, and it solved their problem. And now this kind of problem is becoming more pervasive as well across the industry. And that's why we're seeing a lot of organizations downloading Druid in the Apache community. And there's about 1,000 organizations now that are using Druid. Questions here? Have you come across the discussion around, hey, InfluxDB or Timescale DB, we're using this, but we're hitting this kind of limitation, or users on the data warehouses side saying, hey, this is great from data engineering perspective, where our ETL now takes 5 minutes as opposed to 1 week, but users still want to access their data fast. Have you heard of those kind of stories in the past?
I'm seeing people trying to stream data into data warehouses. So one example is a company that's doing massive amounts of inserts into Redshift, and then they are puzzled when Redshift doesn't work several times each day. So
yeah,
yeah,
got it.
Yeah, and in that case, the advice really is just sit Kinesis fire hose in front of it, and then just use that as a buffer. But I think there's a lot of just practices, because I think to your point, there's a lot of desire to have faster data, more data, but not really recognizing the proper place to ingest that data into. Mm. So I've seen similar things, people trying to use Elasticsearch for like a data warehouse, for example, right?
Yeah.
And then they're like, we can't join everything together. Like, well,
this stretch is too far sometimes, right? Yeah. Another one is HBase. HBase was really a key lookup database, and somehow Salesforce decided to create a product on top of it called Apache Phoenix, which is a SQL layer on top of HBase. And once you start using SQL semantics over HBase, where you're joining different tables and adding aggregates and stuff like that, the performance is not just that good anymore.
Painful.
Yeah, you're putting HBase in the wrong peg, if you will, at that point,
But then I see, InfluxDB. That's used too, mainly from what I've seen by kind of DevOps or people who are more working on the systems for monitoring, and then somebody gets the idea to maybe use that as an analytics database, and then that also has a pretty similar effect. So it just seems like there's I think everyone's intentions are great, right? So it's not like we can.
You can blame them; they love the product, right? And they find ways to use it more, and then they hit a wall, right?
Yeah.
And they're smart to realize that they hit a wall, and they have to look for other place to put what they want to do with the data. Sometimes Pipeline DB is another one that I come across with, which is in the time series databases. And this organization that I work with, their limitation was on the scale of data, and then they have to write code to do the ingest. And a lot of the time, they do that, and they spend a whole lot of time just carrying and feeding the ingest piece of things. And so they didn't want to do that anymore. And so they started using Druid for that purpose, because it solves these two things. Plus, on top of that, allowing them to query their data less than a second guaranteed, and they were able to guarantee it.
Sure.
Yeah.
That's cool. Looks like coming up on time here. I want to be respectful of your time, so I know you have a meeting coming up. So
Me too.
yeah, do we have any? Does anyone have any questions, comments?
I just wanted to say thank you to Joe and Matt for putting this together, and Rommel for your presentation and answering our questions today.
Well, thank you.
You're welcome, bud.
Yeah, definitely. Anytime.
Oh.
Yeah, and I know you had a lot of slides there, Rommel, so we'll maybe have a continuation talk. I know that in the Nerd Herd and also I think in the Salt Lake data communities, there's there's a lot of slides. There's a growing interest in real time. I would say, where Salt Lake and other communities are, it's still kind of data warehousing is king, but the there's also there's this parallel thread where well, I need my insights faster than like yesterday's data. So how do we do that, right?
Exactly.
So and so this is a good topic to keep exploring because it's going to keep coming up over and over again. So definitely appreciate you taking the time to educate us on hot data.
No worries,
man. Sean asked, or Sean had a comment more than anything. His mic's not working. Yeah, don't worry. Rommel actually had the same issue with this camera earlier, so I'm not sure what's up with that.
Oh, no worries.
So yeah,
a question or something?
Yeah, you can type in your question there, Sean, if you want to. If you anything you wanted.
Let me check.
No question. Okay, no question. He's good.
Oh, no question.
Thanks for attending. So, awesome, man. Well, thanks again for doing this, and we'll be back with the Nerd Herd on the 26th. We're going to talk about gut-driven data and all the fun that entails. So
yeah, hey Joe, before we go,
for sure.
Touch on Druid Summit real quick.
Yep.
Yeah, so Druid Summit. Let me just go there and show you. So this is where everybody who are using Druid or has interest in Druid, we are meeting on November 2nd to the 4th, and the theme is real-time analytics at scale. And at this time, we are not sure if we can travel yet, right, due to this COVID restriction. But what we did last April was that we turned it into a digital experience for the Druid Summit as opposed to being, there physically at the venue. So people who have been using Druid will come here and talk about their experience. And this is all coming from these organizations, right? It's not a sales spin. It's more of like educating everybody based on what organizations are doing. And this could be people who have implemented it, solve a problem. This could be business people who came across such a big data challenge and, Druid pretty much made them happy. Or these are people who are writing code for Druid, right? Who are committers to the Druid project in the Apache community talking as well. So there's a lot of stuff here that you can benefit from. So if you're interested, you can register, and I'll send the deck to Joe because all of the things here have their links anyways that you can go through.
Yeah.
Yes, just wanted to point that out.
Cool. Thanks. And I'll post those slides in our Slack channel. So.
Okay.
Yeah. Awesome.
Great.
Well, thanks. This is great. We'll do it again soon. So.
All right. Enjoy your weekend, guys.
Yeah. Take care. All right. Bye-bye.
Bye. Bye.